Hi, and welcome to the Aimtec Academy. Hope everyone is doing well and is ready for this next course. The Aimtec Academy is really the best place to not only learn about Aimtec products, but to enhance your overall knowledge about the power supply industry. Today, we have a very fundamental lesson. Not only will we be covering the basics about power, but we're also going to go over all the different product types that Aimtec offers, as well as talk about two brand new product segments. Without further ado, let's hop into the course. Welcome to Aimtec's Introduction to Power course. So we're going to start this off by talking about voltage. And to talk about voltage, we're going to be using the water tank analogy. So as you see in the diagram, picture that you have a water tank that's filled with water, and then you have a pipe going out of that water tank. So in this case, we would be looking at the pressure, and the amount of pressure within the system or within the water tank is the amount of voltage that we have. So the greater the pressure, the higher the voltage. Said differently, voltage is the measure of electric pressure that forces electrons to flow through a circuit. If we increase the amount of water in the tank, this will actually increase the charge and the pressure. Next, we'll talk about amperage, or said differently, current. Again, using the water tank analogy, the current or the amperage would be the width of the pipe. So a wider pipe will mean that you have more flow passing through your circuit. A smaller opening will decrease the amount of current, meaning that you will have less amperage in your circuit. And the formula to power, which is measured in watts, is simply volts times amps. Finally, we'll talk about resistance, again using the water tank analogy. Resistance is the width of the hose. So if it's wider, there's going to be less resistance when the current passes through the hose. And if the hose is more narrow, there will be more resistance. And the resistance is measured in ohms. Now we'll look at a simple circuit and talk about Ohm's law. So Ohm's law is simply the voltage, which is equal to the current times the resistance. So 1 amp times 1 ohm will give you 1 volt. So we would say that the circuit has 1 volt passing through it. If we double the resistance and keep voltage constant, our current will be halved because the formula needs to hold. So if we still have 1 volt, but we double the amount of resistance in the circuit, we will have twice as much less current. And to quickly go over the diagram, you have the V, and then you have those two horizontal lines, which actually represent a power source, with the plus sign representing the longer bar. This is by convention. And by convention, the current flows from positive to negative, which is depicted with the arrow. Finally, next to the R, you have your resistor. That is the symbol that is used to represent a resistor within a circuit. Now we'll briefly talk about open and closed circuits. A circuit is considered closed when the electricity or the current can actually pass through it. So that would be the diagram on the left. As you can see, we have our battery and a light bulb, and when the circuit is closed, the light bulb turns on. An open circuit breaks the flow of electricity. So on the right, we have no flow of current because the circuit is open. And a simple way to open and close a circuit is a switch, or you can think of a light switch. Now, as we saw a bit earlier, the power measured in watts is simply the current times the voltage. So 1 amp times 1 volt gives you 1 watt. And a watt, or the power, is actually the rate of energy transfer. Now we're going to be moving on to something a little bit more advanced, and we're going to be talking about two different types of currents, starting with alternating current. Alternating current is an electric current that periodically reverses directions, and I don't mean every 6 seconds. It's something that happens very quickly. And AC is current that actually comes from our wall plugs. Even though it's very available, since it's in our wall plugs, it's not practical for powering end customer devices. You could think of AC as a back and forth movement of electrons in a wire, similar to the sloshing of water contained in a bin. If you shake it, the water is going to move back and forth. AC current does this, but at a much faster rate. Now we're going to talk about direct current. So direct current is electric current that actually flows in only one direction. It usually originates from a battery or a power source, and most electric components actually require DC to function. So the two graphs we see on the left, alternating current, which is depicted by a sinusoidal wave. So you have magnitude, which is positive or negative, and that is the representation of it moving forward or backwards, just like the sloshing of the water. And the direct current has a constant positive magnitude over any period of time. So if the circuit is open for 10 seconds, then you'll have a positive, consistent magnitude for that full 10-second period. And now this leads us to Aimtec's ACDC and DC-DC converters. We kind of answered in the previous section why AC-DC converters need to exist is because the input is usually AC-DC, but all the electrical components require DC to function. So as you can see here, AME1-JZ, which is a 1 watt AC-DC converter, will take the AC input, usually from 90 to 264 is what the range is coming out of a wall plug in North America, and it would convert that to a DC current. So it could be 5 volts, it could be 12 volts, it could be 15 volts, depending on what components are being powered by the AC-DC converter. So here's a simple block diagram showing how AC current is converted to DC current to then power different electronic components. So at the entrance, we have the first Aimtec box, which is composed of various AC-DC converters. So we have the AME3 BAZ, the AMEOF3 BJZ, and so on and so forth. And we can all see that they're 5 volt output because they all have 5 after the dash. And these 5 volts can power the LDO, the MCU, the motion sensors, and so on and so forth. On the other hand, on the right-hand side, we have another Aimtec box that contains LED drivers. And since they're AC-DC LED drivers, we don't need to use the DC input from an AC-DC converter to power the driver. We can directly use the AC current coming from the wall or coming from the grid, depending on what the application is. And this converts the AC to DC and then powers the LEDs. Next, we'll talk about DC-DC converters. So sometimes within a system, you have one power source, but you have different electronic components that require different voltages. So instead of having 2 or 3 different power sources, all that we do is we take, let's say, 5 volts, and then we either step it up to 12 volts or step it down to 3.3 volts, depending on what the electronic components require. So in this block diagram, we have the AMEM5, which is an AC-DC converter. And it has a 3.3 output voltage, so it takes the input voltage range of 85 to 264, and it converts it to 3.3 volts. The other Aimtec box has the AIM1LS-NZ and the AIM2LS-NZ, and these are dual output DC-DC converters. So it just means that they have 2 outputs. So it takes the 3.3 volts that is coming from the AC-DC converter, and it converts it to plus or minus 5 volts. And then with these 5 volts, you can power the ADC, the MCU, and the WLAN chip. And below, you have a little excerpt of one of our data sheets for the AIM1LS-NZ, and it shows what the input voltage is, so anywhere between 2.97 to 3.63, and the output voltage is plus or minus 5 volts. So here we go over some typical DC-DC converter uses. If you have a 24-volt battery in a truck, we actually need to step that down to say 12 volts to operate a car radio, CB radio, and or a mobile phone. Where 12 volts from a car battery must be stepped down to 3 volts to run a personal CD player. Where 5 volts on a personal computer motherboard must be stepped down to 3 volts or even 2 volts for one of the latest CPU chips. And finally, where 12 volts must be stepped up to plus or minus 40 volts or so to run a car hi-fi amplifier. And what's important is that when we're actually doing these power conversions, we want to be as efficient as possible. So we want to minimize the amount of power losses that happen due to heat, and we want to convert the maximum amount of power. And the benefits of this is obviously consuming less power, so it's more energy efficient. As well, if you are more efficient, you generate less heat. Now we're going to be talking about Aimtec switching regulators. So a switching regulator is a type of non-isolated DC-DC converter. And unlike the way that we classify our DC-DC converters all based on power, so if we have a 1 watt DC-DC converter or a 2 watt DC-DC converter, switching regulators actually have variable power depending on the voltage and the current. So here again we have another excerpt of our AMSR2-78JZ datasheet. And you see that we have a constant current of 2000 milliamps or 2 amps, and we have variable voltages, so from 3.3 up to 15. And depending on the combination of voltage and current, we have different power. So for example, our first row, so 3.3 times 2000, we would actually end up having a 6.6 watt switching regulator. That would be the power output because, again, if you remember the formula, we don't use milliamps, we use amps. And there are 1000 milliamps contained in 1 amp. So if we move on to the second row, we have 5 times 2000 or 5 times 2, and that's simply 10 watts, and so on and so forth. So depending on the current and the voltage, you can modulate the power within the same series, which means that if your customer designed a circuit or a product that requires 5 watts, and all of a sudden they actually need 10 watts or 15 watts, using switching regulators, you're able to simply remove the old one and place the new one, and it has the exact same size and pins if it's within the same series. So here's a block diagram that we actually use in our UVC presentation. But again, we have a Aimtec ACDC converter at the input of the system, and then the 24 volts that is ejected or that is created by this ACDC converter then powers our switching regulators, which take the 24 volt in and give us 5 volts out. And the benefit of using a switching regulator is that you can achieve much higher power at a lower cost because there is no isolation. It's okay to use a non-isolated DC-DC converter if there will be no interaction between the user and the actual converter. Next, we're going to talk about Aimtec LED drivers. So as mentioned earlier, LED drivers are actually used to power LED arrays. And there are various types of LED drivers. So Aimtec offers AC/DC and DC/DC LED drivers, all depending on the power source. DC/DC drivers are mostly used in the railway industry because of the DC power source. So we also have constant current LED drivers, which are mostly used for LED light fixtures, or constant voltage LED drivers, which are mostly used for LED lights as well as LED strips. So Aimtec offers 3 types of dimming options. The first one is a 0 to 10 volt controller. So this is a dimmer switch that is recognized by the LED driver, and this modulates the voltage. And that would be the image on the left. So as you increase or as you raise the switch, it will increase the voltage, and as you lower the switch, it will decrease the voltage. The next one is a resistive dimmer, and this is the middle image. When the LED driver sees the resistor value change, so either by rotating the resistor right or left, the LED driver recalculates the current to send to the LEDs. So all the resistor does, or all the knob does, is it sends a signal to the LED driver, and the LED driver knows how to interpret it. Finally, we have the PWM dimming. And what's important to understand is that the way that the LED driver powers the LEDs is it sends a signal to the LED. And depending on the period of that signal, you will either have a brighter light or a more dim light. So in the example on the right, if we have a 25% duty cycle, meaning that there is a on signal only 25% of the time, you will have a much dimmer light compared to a 75% duty cycle, which sends the on signal for 75% of the period. So a PWM dimmer is what is able to modulate that pulse and can actually increase or decrease the brightness of the LED. Now we can talk about what an IP rating is, especially when it comes to LED drivers. So IP ratings is what talks about ingress protection. That's what IP stands in the word IP rating. And some of Aimtec's LED drivers are actually IP68. So the first digit talks about foreign body protection, and the 6th level, or level 6, is considered to be dust tight. The second digit of the IP rating is water protection. And what 8 signifies is immersion up to 1 meter in depth or more. And you can see what IP rating various Aimtec LED drivers has because we write them on our datasheet. So below is the extract of the AIM-EPR 60-AZ LED driver datasheet. And as you can see in the features, we can see that there is a waterproof case and it's IP68 rated. And we also added a submersible icon on the datasheet for quick recognition. Next, we're going to be moving on to EMC filters. So as you know, we already have a course on EMC, so if you want to get a more in-depth review of what exactly EMC is and the products that Aimtec offers, please feel free to review that course. But I still will cover a few basics of EMC. So EMC is important as it helps us safeguard our products when exposed to external electromagnetic interference, and also ensures that the emissions from our products meet the required regulations. To understand this better, EMC has been divided into EMI and EMS. EMI stands for electromagnetic interference, and EMS stands for electromagnetic susceptibility. So under EMI, we look at the conducted and the radiated electromagnetic interference. Under EMS, we look at the electrostatic discharge immunity, electromagnetic field immunity, electrical fast transient / burst immunity or surge immunity, conducted disturbance immunity, power frequency magnetic field immunity, voltage dips, short interruptions immunity. So on the left, the top picture is an anechoic chamber, which is what we use to measure the radiated emissions, and the bottom picture is an example of how we would measure the conducted emission. And Aimtec has various products that can help you with your EMC compliance. So we offer ACDC EMC filters, we offer DC-DC EMC filters, and then we have common mode chokes and surge suppressors. Again, if you want to know more about how these products can be used in specific applications, please have a look at our EMC course that you could find right here in the Aimtec Academy. Now, Aimtec is very excited to talk about this next product category because it is a brand new one for us, and this is high power AC-DC conversion. This is our brand new high power AC-DC converter that can go up to 320 watts. Within the series as a whole, we'll be reaching power of 350 watts, and you can distinguish these models because you will have our brand new high power icon on the label. So this brand new category goes from 35 watts all the way up to 350 watts with PFC and non-PFC variants. The new enclosed power supplies undergo multiple stringent testing and engineering verification procedures to ensure outstanding performance and reliability. So here are a few highlight features that we'd like to talk about in this course. So first off, we have excellent low temperature startup. Without going through any preheating process, the new non-PFC enclosed power supplies can be started up within 4.5 seconds at minus 30 degrees Celsius, while the PFC variants need only 2 seconds. Point number 2, reliable performance. This series delivers high reliability even at high ambient temperature environments. The capacitor lifetime evaluation method ensures the capacitors will last for a minimum of 5 years while operating at 70 degrees Celsius. We also offer terminal customization. To satisfy the various needs of our customers, these series offer customized solutions including conformal coating for application environments with high humidity and terminal covers for application environments requiring high safety and prevention from accidental shorting of the terminals. Finally, EMC performance is great with these models. So adding extra EMC components to enclosed power supplies can be troublesome. With this in mind, Aimtec's new enclosed power supplies are designed to deliver stable EMI and EMS performance even in high temperature environments. The stable EMC performance can ensure the reliability of the end products. And again, we have recently launched part of these models in our latest price list, and the rest will be available to you shortly. Again, Aimtec, always looking for new ways to innovate, always looking for new ways to grow our product portfolio in the most efficient and effective way possible, will also be entering the adapter market. So Aimtec will soon be launching these new AC-DC adapters. These products are designed to be powered directly from the wall and can be used in either a wall plug or desktop type configuration. The wall plug variant can be customized with different plug types depending on the country of use. Aimtec wall plug adapters can be ordered with input plug types that are compatible with the different sockets used around the world, including the United States and Europe. The desktop adapters are like laptop chargers, where you have a cable supplying power from the wall to the adapter instead of having the adapter plugged directly to the wall like a wall adapter. So the image on the left is actually a desktop adapter with a special terminal. And you would have the power cable plug into the rear of the adapter, and that you would go directly into the wall. The output side of the adapters can be customized depending on the application. There are many types of DC jacks with different sizes and locking mechanisms that are used by end applications. Depending on the type needed, the correct version can be selected and ordered. So these output connectors range from the standard output connector that you would see on one's laptop all the way to USB Type-C outputs. Many governments now require adapters to be more efficient, have lower no-load power consumption, and comply with safety and EMC regulations. Aimtec adapters, of course, meet or exceed these requirements and are well suited for our applications. Well, everyone, thanks for tuning into the Aimtec Academy. This concludes our course on the Intro to Power Basics, as well as covering the broad product offerings that Aimtec has. We also wanted to thank you for taking the time to go through the training material to really invest yourself in increasing the overall knowledge that you have about not only Aimtec, but of the power industry as a whole. And we will see you in the next product training.